In this lesson, we'll take on our first real project, building a complete KeyShot scene around a pair of headphones. Along the way, we'll face the kind of challenges that come up in real workflows, from preparing the model to shaping light and mood. By the end, you'll see how everything comes together to form a polished, professional result. To kick off this project, let's take a quick look at the chapters that shape this lesson. This graphic lays out each chapter in sequence, giving you a clear view of the steps we'll follow from start to finish. Not only will this recurring animated graphic help you see what will be learned and when, but it will also serve as a progress indicator, motivating you to continue watching the lessons until project completion. Keep in mind that KeyShot allows for many valid workflows. What you see here represents one structured path, not a fixed rule for how every project should be built. With KeyShot Studio launched, we can import our 3D model by simply navigating up to the top left corner, clicking on File, Import, selecting our 3D model, and then clicking Open. The default import options work perfectly fine for us here, so let's proceed by clicking Import. Okay, perfect. We've now imported our 3D model into the scene. But this phase of the project is not only about importing the 3D model, it's also about preparing it for rendering. So what does that mean? To prepare our model for rendering, let's do what's called a CAD audit. A CAD audit is a quick quality check on your model, making sure parts are cleanly separated, edges are properly filleted, and that the overall model is scaled accurately. Let's start with our need to check that our model has separated parts. By clicking on all of the parts of our headphone model, we could start to notice that this is actually just all one part, merged together. We can verify this by clicking into the Scene tab and clicking on the drop-down next to our 3D model. By expanding this drop-down, we can click the only part which belongs to this model and hide it. Having a 3D model that is a single part is problematic for rendering because we'll want to apply different materials to different parts. But if we can't select those parts, we won't be able to target them when it comes time to adding materials. So what is there to do? Well, while there are tools in KeyShot which could be used to separate surfaces and objects, it's best practice to anticipate material breaks and color block your 3D model while still in the CAD phase of your project, before you start working in KeyShot Studio. When this model is re-imported into KeyShot Studio, it arrives properly segmented and ready for material assignment. Each part is now clickable, and the scene tree confirms that they're properly recognized as separate elements. You can't always anticipate every part break, however, by first color blocking them in CAD. For example, let's look at this part of our headphone model. With the part selected, we could then right-click on the part and select Solo Mode. This isolates our part and makes it easier to see the entire thing. What if we want to be able to target just the outside surface? Here you can see that this currently isn't possible, as the entire cylindrical body is selected if any area of this part is clicked on. Instead of going back into our 3D model and color blocking the surface and then re-importing into KeyShot Studio, let's now show how you could separate surfaces in KeyShot. To do this, go up to the top of KeyShot's interface and click on Tools. The Tools tab houses a collection of utilities that let you modify and prepare different aspects of your scene directly inside KeyShot. This includes tools for working with geometry, as well as tools for materials, cameras, and lighting. We'll be utilizing one of the geometry tools, specifically the Split Object Surfaces tool. The Split Object Surfaces tool in KeyShot lets you divide a single object into multiple surface regions directly inside the scene. This tool works by using face angles to determine where one surface region ends and another one begins. By clicking on our object here, we can see that KeyShot still isn't recognizing where one surface starts and another one begins. To fix this, we need to reduce our splitting angle. The splitting angle acts as a threshold. Faces that fall within the angle range are grouped together and treated as part of the same surface, while faces that exceed the angle break are separated. In practical terms, a lower splitting angle limits the selection to flatter, more continuous areas. After lowering the splitting angle, clicking an empty space to deselect, and then reselecting our object, we could see that we're now able to target just the outside surface of our part. After clicking Split Surface and then selecting Apply, we can then come back to our scene to confirm that we've successfully split this object surface. The next step in the CAD audit is to confirm that every edge in your 3D model has a fillet. A fillet in CAD is a rounded transition between two surfaces, used to soften the sharp edges of your design. You may be thinking, I have a sleek, modern design with very crisp, sharp-looking edges. I can't add fillets, otherwise I'll lose the design intent. Even if that were the case, it's still strongly advisable to add small fillets to your 3D models before bringing them into KeyShot Studio. The reason you want rounds on every edge of your product is so that once you render your model, the highlights will catch on the edges. Let's look at this rendering first. At a glance, it works, but notice this shadowed area. It collapses into a near black hole. In reality, you would expect to see at least some reflected highlights along the edges. The issue is the geometry. This pattern is built with infinitely sharp edges, which gives the rendering engine nothing to catch light. Now let's look at the same object under the same lighting, but this time the pattern uses filleted geometry. When you switch back and forth between these two renders, the difference becomes clear. The rounded edges introduces subtle highlights that define the form, break up flat shadows, and add realism, even though the change in geometry is minimal. Here's another example of why fillets matter so much in rendering. In this first render, the model uses infinitely sharp edges, which causes details to disappear into shadow. In the second render, those same edges are slightly filleted. With that small change, the light has something to catch, and suddenly the numbers and markings on the caliper become readable. Let's now take a closer look at our 3D model and evaluate whether it's ready to render. As we inspect the edges across the model, everything looks to be in good shape. Each edge has a fillet, which will allow highlights to catch naturally under lighting. All parts except this one. This piece still has perfectly sharp edges, which means light has nothing to grab onto. As a result, highlights will not appear properly in the final render. To fix this, you could go back into CAD, add fillets to this part, and then re-import into KeyShot. This works, but it's tedious.
Luckily, there's a way we could simulate rounded edges for our sharp parts right in KeyShot Studio.
To do this, click on the part with sharp edges. Then, with the Scene Properties tab selected, scroll down until you see Rounded Edges. Rounded Edges is a material-based shader in KeyShot that visually simulates filleted edges by modifying how light and shading behave near sharp geometry. This effect works best at subtle radius values. Pushing the radius too high causes the result to break down and appear unnatural. That's because rounded edges does not modify the model's geometry, it only affects how the edges are rendered. When viewing this cube from above, it's clear that the edges are still perfectly square. The rounding only exists in the render, not in the geometry itself. After returning to our scene, we can now use this information in order to add a small radius to our infinitely sharp geometry.
The final part of the CAD audit is all about scale. One thing that's easy to overlook, but incredibly important, is working in the correct scale. When scale is correct from the start, materials behave more realistically, lighting behaves more predictably, and camera settings like depth of field make more sense. The best practice is to ensure your model is accurately scaled before you even get to KeyShot Studio. However, once a model is inside KeyShot, there are still ways to verify and correct scale. The first thing to check is your scene units. In the top toolbar, you could define whether your scene is working in meters, inches, centimeters, millimeters, or feet. These units should match the units that were used when the model was created. If the units are mismatched, objects may appear dramatically too large or too small, like this scene here. Here we've just imported two 3D models, and one clearly needs to be adjusted. Your tendency might be to select the pizza and use the Move tool to scale it down to an appropriate size. This works, but you're just guessing. Who's to say the toaster isn't the model that needs to be scaled? To verify what size your model is, simply select it in the scene tree, and then click into the Properties tab to evaluate its size. 70-inch pizzas only exist in the dream realm, so we know it's the pizza that needs to be scaled appropriately. Another more visual approach to checking the scale of your scene is to click into KeyShot's Cloud Library and download a human dummy model. After downloading, this model will now appear in the Models tab here in your library. It can be dragged into your scene to serve as a quick reference for scale.